Okay, let's start with NEET solving questions, that is from circular motion. Circular motion is a topic and not a chapter. Circular motion. Question solving. Let's start it then. First question. A particle of mass m is tied to a light string and rotated with a speed v along circular path of radius r. If tension in string and mg gravitational force on particle then the actual forces acting on the particle are. They're saying that a mass of m is tied to a light string, meaning it's a massless string, and it's rotated with a speed of v, velocity v, along a circular path having a radius of r. If tension T is in the string and gravitational forces acting on the particle, then the actual forces acting on the particle are option A mg, that is gravitational, and T only, B mg comma T and mv square by r inwards, C mg T and mv square by r outwards, T only mv square by r inwards. They're saying that a particle is moving in circular motion which is tied to a light string. The two forces acting on it are the gravitational force and the tension. Then what is the actual forces acting on the string? The correct answer is option A, that is mg, that is gravitational force, and tension only. A particle moves in circular motion because there is a force acting on it. If this force is acting on it towards the center, that is only called the centripetal force. This is the equation for centripetal force. We don't need this. The only forces acting are mg and t. If they are acting inwards, then it will go in circular motion. If they are not acting inwards, it will not go in circular motion. It is going in circular motion, meaning these forces are acting in such a way that they are creating a centripetal force. They're acting as a centripetal force. So it's option A. Anyways, now let's go to the next question. Now, next question is, a bob is whirled in a horizontal cycle of a string at an initial speed of 10 rpm if tension in the string is quadrupled while keeping the radius constant, the new speed is options 20 rpm, 40 rpm, 5 rpm, and D 10 rpm. They are saying that there is a bob. It is whirled in a horizontal cycle or circle of a string at an initial speed of 10 rpm. The initial speed is 10 rpm. If the tension in the string is quadrupled, the tension got quadrupled while keeping the radius constant. The new speed is they're asking. Now tension, which is equals to m omega square r, which is basically the centripetal force, because we know m omega square r is the basically mv square by r, which is equals to centripetal force, and in this case the centripetal force is tension. Now we know the relation v, which is equals to omega r, which gives v. So v square m omega r whole square by r. This we can write as m omega square r into r by r cancel. We will get that tension, which is equals to m omega square r. Now initial tension by final tension T2, this is final tension, let's assume, by T1, which is equals to m omega 2 square r by m omega 1 square r. Radius will remain constant, mass will remain constant, cancel. So T2 by T1, which is equals to omega 2 by omega 1. We can take it as omega 2 by omega 1 whole square. Now we know that they said tension 2, which is equals to 4 times of tension 1. So 4 T1, which is equals to 1 T1, T1, T1 cancel, which is equals to initial angular momentum, that is, I believe, this one, the above one, the omega 2 is not given. Omega 1 was given to be 10 rpm whole square. Now it will go that side. 2, which is equals to omega 2 by 10, omega 2, which is equals to 20 rpm. So option is option A. Let's go to the next question. Let omega 1, omega 2, and omega 3 be angular speed of the second hand meaning the clock's second hand, minute hand and hour hand of a smoothly running, meaning frictionless, analog clock, respectively. If x1, x2, and x3 are their respective angular distances, in 1 minute, then the factor that remains constant, that is k, is options omega 1 by x1, which is equals to omega 2 by x2, which is equals to omega 3 by x3, that will be equal to k. Option B, omega 1 x1, which is equals to omega 2 x2, which is equals to omega 3 x3, which is equals to k. C, omega 1 x1 whole square, which is equals to omega 2 x2 whole square, is equals to omega 3 x3 whole square, which is equals to k. Option D, omega 1 square x1, which is equals to omega 2 square x2, is equals to omega 3 square x3, is equals to k. They are saying that in a clock there are three hands and each hand is moving with angular velocity omega 1, omega 2, and omega 3, and it covers a distance of x1, x2, and x3 respectively, that is angular distance, in 1 minute. Then which of them will remain constant? The answer is the first option. How so? Because in 1 minute, if we take omega, which is equals to solution, omega, which is equals to 2 pi by t, then we know that omega, we can write it as x or theta. Here, since they took x, we'll write it as x by t, which is equals to 2 pi by t. Now this again we can write it as x, which is equals to 2 pi by t. This is x and this is omega. Two things they gave in our question. Now let's divide them. We will get omega by x, which is equals to 2 pi by t by 2 pi by t times t. You will get it as omega by x, which is equals to 1 by t. Okay, in both cases, what is constant is time. Time is constant in both cases. As for 1 minute we take, time will be constant, or x by omega is also constant. If there was an option as x1 by omega 1, which is equals to x2 by omega 2, that is also correct. Now finally the answer is option A. The next question is, a 2 kg stone At the end of a string 1 meter long is whirled in a vertical circle at a constant speed. The speed of the stone is 4 meter per second. The tension will be 52 Newton. The tension in the string will be 52 Newton. When the stone is, okay, let's see the options. At the top of the circle, B at bottom of the circle, C halfway down, D none of the above. Okay, let's see again. There is a 2 kg stone at the end of a at the end of a string 1 meter long. Radius is given 1 meter and is whirled in a vertical circle. Yes, the at the end of a string, it's 1 meter long. It's whirled in a vertical circle at constant speed. The speed is 4 meter per second. It's a constant speed. The speed will not change here. If that is the case, at what position of the vertical circle the tension in the string will be 52 Newton? Now let's calculate the centripetal force mv square by r, which is equals to 2 is the mass, 4 is the velocity, 4 square, that is 16, by radius is 1 meter, so 32 Newton is the centripetal force. This is inwards, and mv square by r, this is at the top position. Now this is 32 Newton, this is the tension, and we know tension minus mg, which is equals to mv square by r. So tension, which is equals to minus mg minus 2 into 10, is equals to mv square by r, 32. We will get it as t, which is equals to 32 plus 20, and this is at the lower position, because at the upper position there won't be tension in the string. Gravitational, only gravity will act as the force. So 52 Newton we will get at bottom of the circle. Let's go to the next question. A conical pendulum is moving. A pendulum is nothing but a bob that is connected to the end of a string, same as we saw before, but a fancy way of saying it, that is called as a pendulum, in a circle with angular velocity omega. If tension in the string is T, which of the following equations is correct? Now they gave the motion here. It's moving. Um, this is the circular motion. This is the bob. The length is L, the length of string, and this angle is theta. Now the equations given are A, tension which is equals to m omega square L, B, T sine theta which is equals to m omega square L, C, T which is equals to mg cos theta, D which is T which is equals to m omega square L sine theta. Now they said there is a conical pendulum. It is moving like this. The bob is rotating like this. This is the tension acting. Now, if these are all equations for tension, then in which of these equations is correct? And obviously the answer is the first one because we solved it before in our previous question here, where we got tension which is equals to m omega square r, m omega square r. So here also it is holding true here. And as for T sine theta, the equation should be mr omega square. Okay, so the answer which we know directly is Tm omega square L. That is for normal tension. Now let's go to the next question. The question is two particles A and B start at the origin O and travel in opposite directions. Along the circular path at constant speeds of 0.5 meter per second, 0.5 meter per second, and 1.5 meter per second, the time they collide with each other is the time when they collide with each other is. Okay, they gave the diagram here. This is the center of the circle. Radius is 0.5 meter. This is origin. Y-axis, x-axis. Now one particle starts Va starts with Va, which is equals to 0.5 meter per second, and one more particle start this side with Vb, which is equals to 1.5 meter per second. 1.5 meter per second. Now they are asking that this the two particles A and B start at origin and travel in opposite directions along a circular path at constant speeds of 0.5 and 1.5 meter per second. The time that when they collide with each other is. Now the options given. Actually, let's just find the answer here. 0.5t plus 1.5t, which is equals to 2 pi r. How we got this is velocity times the time taken, which is the total distance that can cover, velocity times basically velocity, which is equals to x by t, v times t, which is equals to x, the total displacement covered by the first particle, that is a particle here, times total time, and 1.5 is the second velocity particle vb, and time taken, the total they can cover is 2 pi r, that is the circumference of the circle. And if we take 2t, which is equals to 2 pi r, t, which is equals to pi times 0.5, 0.5 is radius, so we can write 0.5 as pi by 2. So pi value, you know it as 3.14 by 2, which is equals to 1.5 seconds, 57 seconds. Basically, we need to know this formula to solve this question. 0.5t plus 1.5t, which will give to 2 pi r, which will give 2 pi r, that is the total distance. Now let's go to the next question. Okay, let's do this question. This is a little lengthy question. Now, two thin rods connected in a truck is rotating about their own axis with angular speed omega 1 and omega 2 in same sense, and a separation between them anyways. Separation between them is L. Two men, Ram and Sham, are rotating with them with the rods as shown in figure. I will draw the figure. The truck is moving horizontally with acceleration A. Mass of Ram and Sham are same and individually equal to n and equal to m. The centrifugal force as seen on Sham as seen by Ram is, the diagram is something like this. This is a truck. It is moving with acceleration A. There are two rods here. There is a person here. And there is one more rod here. One more person here. They are rotating with omega 1 and omega 2 in same direction as the length. The separation between them is L. Now I'm reading the question again. There are two thin rods connected in a truck and is rotated about their own axis with angular speed omega 1 and omega 2 in same sense, and a separation between them is 2L. Basically they're saying rods are rotating, the people are also rotating in same direction, and separation between the two rods is L. There are two men, Ram and Sham, rotating with them, and the truck is moving horizontally with an acceleration of A. Mass of Ram and Sham are same. The centrifugal force on Sham as seen by Ram. This centrifugal force is actually a pseudo force. Solution, or basically let's give the options first. ml omega 1 square, ml omega 2 square, ml omega 2 square, omega 1 minus omega 2 whole square, d 0. This is the question is the centrifugal force on Sham as seen by Ram. Like what is the force seen by Ram on Sham? So centrifugal force is a pseudo force. So pseudo force is equals to mass times acceleration frame. Centrifugal force is equals to mass of Sham times acceleration of Ram, because this is on Sham, force on Sham seen by Ram, which is equals to m omega 1 square times L. So it is option 1. Next example. The second hand of a watch has length 3 centimeter. Find speed of the tip of the second hand. Okay, no need for option for this. They're saying that the second hand of a watch has a length of 3 centimeter. Now find the speed of the tip of the second hand. Velocity, which is equals to 2 pi r, and 2 pi r by t. 2 pi by t is omega, so omega r. Velocity, which is equals to 2 pi times radius is 3 centimeter, or we can convert it into meter by 10 power minus 2 by total of 60 seconds. It will move a total of 2 pi r distance for 60 seconds. So velocity is equals to 1s are 30s are, 1s are 10s are, pi by 10 into 10 power minus 2, which is equals to pi into 10 power minus 3 meter per Second, let's go to the next question. A particle is moving with constant speed in a circular path when the particle turns by an angle 90 degrees. The ratio of v instantaneous to its average velocity is pi is to x root 2. The value of x will be. Okay, no need for option for this. They're saying a particle is moving with a constant speed in a circular motion. First, it's moving in a circular motion. When the particle turns by 90 degrees, the ratio of instantaneous to its, okay, it's covering 1/4 of the circle. Then the ratio of its average velocity to instantaneous is x root 2. Pi is to x root 2. In circular motion, we know that velocity which is equals to instantaneous velocity which is equals to t omega, and average velocity is total displacement by total time. V instantaneous which is equals to not TR, T omega which is equals to R omega. This is V instantaneous, and V average which is equals to displacement by time. Omega we can write as V instantaneous is equals to R times of omega which is equals to 2 pi by T. And when we compare with V average, we will get as displacement by time T here is time period to complete one whole revolution. I'll see this question again later. Let's go to the next question. A particle crosses the topmost point C of a vertical circle with critical speed, then the ratio of velocities at point A, B, and C is where the points are B, A, C. 90 degrees. This is point O. Okay, basically we know that critical velocity VC, which is equals to root of gr, radius times the acceleration whole root, where r is the radius of the circle of the path. Now if VA we take VA square plus VC square plus 2G times 2R is equals to VA square, that is GR plus 4GR, which is equals to 5GR. So basically we got VA, which is equals to root of 5GR. And similarly VB square, which is equals to VC square plus 2GR, which we will get VB, which is equals to root 3GR. Then we will get VA is to VB is to VC is equals to root 5 is to root 3 is to root 1 or 1. Next question. Let's go to the next question. A particle moves with constant speed v along a circular path of radius r and completes the circle in time t. The acceleration of the particle is, okay, they're saying a particle moves with constant speed along a circular path. A particle is moving in a circular path with speed v and the radius of the circle is r. It completes the circle in time t. Then the acceleration of the particle. Okay. The particle undergoes centripetal acceleration, that is centripetal acceleration, which we know which is equals to v square by r. Centripetal force is mv square by r, so it is v square by r is the acceleration, and v, which we know it as 2 pi r by t, that is what they gave here, and the acceleration which is equals to 2 pi r by t whole square by r, that is the acceleration which will get it as 4 pi square r square by t r, cancel, r square cancel. Now we can write it as 4 pi, we can take outside, we can write it as, I mean, not 4 pi, 2 pi we take it outside, 2 pi we take it outside, we can write it as 2 pi, 2 pi r also, no, we should keep r, yes, we should keep r, 2 pi r by t, and yes, there is t square as well, so t square, there will be one t here, and this we know it is velocity, so acceleration, centripetal acceleration equals to 2 pi v by t. We did that because there is an option, that is 2 pi v by 2 pi v by t. Now let's go to the next question. A particle is suspended from a string of length r. It is given a velocity which is equals to 3 root gr at the bottom. This is u, let's take it as u, is equals to 3 root gr, that is at the bottom of the circle. Find velocity at point B. There is a circle. This is the bottom of the circle, that is at point A. This is U. At point B, 90 degrees. Radius is R. Now what is the velocity at B? We'll get final answer V, which is equals to VB, which is equals to root 7 GR. I'll see this later again. Answer is root 7 GR. Let's go to the next question. That is a heavy small sized sphere is suspended by a string of length L. The sphere rotates uniformly in a horizontal circle with the string making an angle theta with the vertical. The time period of this conical pendulum is. Okay, they are saying that this heavy small sized sphere, it's a heavy sphere, meaning it is having a mass, it is small, it is suspended by a string of length L. The sphere rotates uniformly in a horizontal circle with string making an angle theta with the vertical. Then the time period of this conical pendulum is. Where time period solution, time period is equals to 2 pi root of L cos theta by G. Now let's go to the next kind of question. I will come back to this again once. two cars having masses m1 and m2 move in circles of radius r1 and r2 respectively if they complete the circles in equal time, the ratio of their angular speed. That is omega 1 by omega 2 is. Options A is m1 by m2, B is r1 by r2, C is m1 r1 by m2 r2, D which is 1. They're saying that they complete circles in equal time, meaning time periods are same. Solution, they're asking angular velocities here, not velocities. Angular velocity which is equals to 2 pi omega 1 by 2 pi omega 1 which is equals to 2 pi by t1 and omega 2 which is equals to 2 pi by t2 t1 and t1 which is equals to t2. So omega 1 is equals to omega 2 and omega 1 by omega 2 cancel which is equals to 1. So the answer is option D, that is 1. Let's go to the next question. There are assertion reason questions here. First question, in a circular motion, work done by centripetal force is always 0. In circular motion, work done by centripetal force is always 0. This is a correct statement. True, because work done is equals to F dot D or Fd cos theta. In centripetal force, it is that theta is basically 90 degrees, the angle between displacement and centripetal force is 90 degrees, cos 90 is 0. So work done is equals to 0. Statement 1 assertion is correct. Reason, centripetal force is always perpendicular to instantaneous displacement. That is what I said here. So reason is also correct with correct explanation. Now next question. Next question is, a car of mass 1000 kg negotiates a banked curve of radius 90 meter on a frictionless road. If banking angle is 45 degree, the speed of the car is, okay, they're saying a car of 1000 kg mass is negotiating a banked curve of radius 90 meter on a frictionless road. If the banking angle is 45 degrees, then the speed of the car is. If there is no friction, then the only force that is providing the car from not getting uh, drifted is due to the normal force. I mean, due to the centripetal force, that is the normal force. When there is no friction, the formula is V, which is equals to root of Rg tan theta. V square is equals to Rg tan theta. Now substituting the values, you will get V, which is equals to root of R, they gave 90, times G 10, tan 45 is 1. V, which is equals to 30 meter per second. A body is moving with constant speed in a circle of radius 10 meter. The body completes one revolution in 4 seconds. At the end of third second, the displacement of body that is in meter from its starting point is, they're saying our body is moving with constant speed in a circle of 10-meter radius. The body completes one revolution in 4 seconds. At the third second, the displacement of the body is. Now solution is theta, the angular displacement, which is equals to, okay, they're saying that, let's first see omega. A body is moving with constant speed in a circle of radius 10 meter. So omega which is equals to 2 pi by 4, angular velocity which is equals to omega which is equals to pi by 2. We do not need to consider radius in case of angular velocity. Then they're asking the displacement of the body at third second. Velocity we will get as pi by 2 times 10 meters, that is 5 pi, that is velocity. Velocity is 5 pi. Then velocity which is equals to displacement by time. So at 5 pi times t at 3 seconds, which is equals to displacement, so 15 pi. Okay, but we are not finding that displacement here. We are not finding distance here, we are finding displacement. So we need to take this path here, which, if this is radius and this is radius, this will be r root 2. And since it is actual displacement from starting point, what we found is distance here, that is 15 pi. But displacement, which is the direct path from here to here, that is directly r by 2, I mean r root 2. And displacement which is directly equal to r is 10, so 10 root 2. Next question is, the next question is, a spaceman during training period is rotated in a seat at the end of a horizontal arm of length 5 meter. If he can withstand acceleration up to 9g, then what is the maximum number of revolutions per second permissible? They're saying that a spaceman during training period is rotated in a speed seat at the end of a horizontal arm of length 5 meter. We can withstand gravitational acceleration up to 9g, then what is the maximum number of revolutions per second? They gave a radius which is equals to 5 meter, and centripetal acceleration is equals to 9g. AC is equals to 9g. Number of revolutions per second, which is equals to 1 by 2 pi root of 9g by r, that is 0.5. We substitute, we will get n, which is equals to 0.675 revolutions per second.